In our next section, section 3.6, we're going to put everything that we've talked about in this unit together. Everything you know about where a function is increasing, where it's decreasing, where it's concave up, concave down, points of inflection, relative extrema, all that stuff. We're going to put all those ideas together and figure out how to, eventually, take the formula for a function, go through a lot of analysis of it, and get a good sketch of that function. We're going to spend 2 days on this. We'll look at reasonable-ish functions today and more complicated functions tomorrow. To get us started, though, in section 3.6, what we need to realize is every single function is really made up of only 4 different shapes based on increasing, decreasing stuff and concavity stuff. One shape that our function could take on is a shape that is concave up and increasing. That would be actually, why don't I call this increasing and concave up. Another shape that I can take on is something that is decreasing, but also concave up. Well, a third shape would be increasing, but concave down, like that. Increasing, but concave down. I think you can figure out the last shape. See if you can figure out the last shape. I need something decreasing concave down. It's going to look like this. Decreasing and concave down. Every graph that we look at will just be made up of combinations of these 4 different shapes. Let me show you what I mean. Take a moment and please take out the packet that you have titled Intro to Graphing Polynomial Functions. Section 3.6, Intro to Graphing Polynomial Functions. Take this out, and then I'd like you just to take a moment and plot all these points over here. Edpuzzle's going to pause. Get those points on your graph. Got an x-intercept at -3, 0. Another one at 1, 0. Another one at 4, 0. Y-intercept at 0, 12, so about there. Relative max at -1, 20, so about there. Relative min at 2, -15, so about there. And I think I could get a relatively decent sketch of my graph by just going through the points, but I want to be a little bit more precise. Below the graph, you have 3 number lines stacked with the tick marks matching up with each other, like -1 here is in the same place as -1 there, and also matching up with tick marks on the graph that you have. Let's ignore that first number line, that f number line, and I'd like to take a look at the f prime number line. F prime tells us if our original function f is increasing or decreasing. So I'm going to take a moment, I'm going to fill in my little increasing and decreasing symbols. I know I'm increasing where f prime is positive. I know I'm decreasing where f prime is negative, and then I'm increasing again where f prime is positive. And I think I'll use a darker pen for the next one. The number line below that is information about f double prime. Well, I'm going to fill in my concavity symbols. Where f double prime is positive, I'm concave up. Oh, that's darker, I think. Where f double prime is negative, I'm concave down. So I'm going to look like this. What I'm then going to do is create a third number line, one that I'm just going to label as f. The tick marks that I'm going to put on f will just involve consolidating all the tick marks that I have in f prime and f double prime. So I've got a tick mark at -1, 2, 1. I'm just going to put all those tick marks on my f number line. And again, I do want all the tick marks to match up, and also to match up with the tick marks on my x-axis on the graph. On my number line for f, I'm going to fill in those shapes that we just put in our notes. What I mean by that is before -1, I'm increasing, and I'm concave up. That means I want a shape that looks like that, increasing and concave up. Between -1 and 1, I want to be decreasing. You know what? I just said that wrong. I didn't mean increasing concave up. I meant increasing concave down. Sorry about that. I drew it correctly. I said it wrong. Between -1 and 1, I want to be decreasing and concave down. So I want a shape like this. Between 1 and 2, let's see, my concavity is positive, so I want to be concave up. And I want to be decreasing, because my first derivative is negative. Concave up decreasing is one of those. And finally, from 2 to infinity, I'm concave up, I'm increasing. I want to take on a shape that looks like that. All that I need to do now is fill these ideas in on my graph. Those points that I plotted, those are kind of anchor points that are going to help me with the shape of the graph. I know my graph has to go through those points, but as far as the shape between them goes, I'm going to get that from this top number line. What I mean is until I get to -1, in particular that max at -120, I need to be concave down, increasing. So I'm going to fill that in. I want to go through the x-intercept because it's there, and it's going to look something like that. Concave down, increasing. Next, between -1 and 1, I want to be concave down, decreasing. So I need to be concave down, decreasing from here to here. And I just have to make sure I also pass through that extra point that I have on there, my y-intercept. So, kind of like that. I'm then going to switch to concave up, decreasing. Kind of like that. And I'm going to end by being concave up, increasing, and just need to make sure I hit that x-intercept over there. And my graph is going to look something like this. Now, normally, I won't just give you tables already kind of filled in with positives and negatives and those things. You're going to have to figure out those values based on everything we did in sections 3.3 and 3.4, where I give you a formula, you find the first derivative, you find the second derivative, and all that stuff. We'll get there later. Really, this is the only new piece, the idea of putting it all together with a graph. So I want to focus on this skill right now. Then we'll look at 2 examples in the next video that put everything together. I'm going to make the video pause if you need another moment to copy any of this stuff down. And then let's go on to problem number 2. What I want you to do right now is fill all these points in on the graph, and then ignore your F number line for right now. Just fill in your symbols on the F prime and the F double prime number lines. Your increasing, decreasing symbols on F prime, and your concavity symbols on F double prime. I'll make Edpuzzle pause the video. Let's see, I want to point at 1, 10. I want to point at -2, 0. I want to point at 4, -20. See you later, Mrs. Reap. I want to point at 0, 5. I want to point at 2, -5. I've got my points. Filling in the number line, I should have symbols like this. I want to be decreasing, increasing, decreasing, increasing. I want to be concave up, concave down, concave up. Let's see what we can do on our number line. Until I get to -2, I want to be concave up, decreasing, so it should look like this. From -2 to 0, I want to be concave up, increasing, so it's going to take on a shape like that. See if you can fill in the rest of that top number line. Concave down, increasing, one of these. Concave down, decreasing, one of those. Concave up, decreasing, one of these. Concave up, increasing, one of those. We're now going to put this together on the graph. And I didn't give you x-intercepts in general and y-intercepts other than this one over here, so I'm just going to kind of go through wherever seems appropriate enough. I need to start with being concave up decreasing until I get to my relative minimum at negative 2, 0. Well, that's going to look kind of like that. I then need to switch to concave up increasing until I get to x equals 0. So until here, concave up increasing. Then I'm switching to concave down, increasing this shape until I get to 1, 10. Concave down decreasing between 1 and 2, so kind of like this. See if you can fill in those last two parts. I want one of these, and I want one of those. Ooh, hopefully you can see that graph. Let me make it a little bit darker. Maybe. And we should get something kind of like that. Let's take a look at number 3. If I remember correctly, yeah, there's not a lot going on in number 3. See if you can do the entire thing. The points, the number lines, the graph. Point of inflection at negative 1, 10, and that's all I told you. Increasing, increasing. Concave down, concave up. I want one of these. I want one of these. I think I'm just going to look like this. And I'm gonna then look like that. That's it. Not super exciting. I think there's one more in this packet of notes we're gonna take a look at. Problem number 4. This one's a little bit different. They gave us some information in a table. I want to make my number lines, put tick marks on my number lines, all that stuff, and then get the points and all that. Well, any points that I have are going to come from that first row, my f of x values. I know, for example, 2, 1 is a point on my graph. 4, 4 is a point on my graph. 6, 7 is a point on my graph. Because of the way the table was set up, I should probably put some tick marks at 2, 4, and 6. So let me go do that on all 3 number lines. Oops, you can't see that bottom number line. Sorry about that. Let's see, zoom out so we can see all this stuff all at once. Okay. And then, you know what? I think you can get your signs from your table. See if you can fill the signs in, put your symbols in, get your shapes, and then stop. We'll do the graph after we've checked all the other stuff. Negative, positive, positive, negative. Okay, so decreasing, increasing, increasing, decreasing. Concave up, concave up, concave down, concave up. I need one of these. I need one of these. And one of these. And one of these. Let's now try to put it together. And it's going to be a little strange in some parts. I want to be concave up decreasing until I get to this point over here. So, kind of like that, whatever. Then I want to be concave up increasing until I get to the point at 4, 4. By the way, I told you that f prime of 2 was 0. Yeah, sure, looks like my derivative at x equals 2 is 0. I said the second derivative was 3. I don't know that for sure from my graph, but I know that because the second derivative is positive, I'm concave up, and that's all good. I then want to be concave down increasing. So it'll look like that. Ew. I need to be concave up decreasing. That's going to be a little tricky. But notice, my derivative at x equals 6 doesn't exist. I'm going to have a sharp turn on my graph, and things are going to work. I'm going to get something kind of like this to finish it off. And that's my graph. And actually what we just did in this problem number 4 is the second to last problem, so similar to the second to last problem that you're going to have on the portfolio, creating a table with some information like that, and then filling things in over there. And I think that's all I have to say about this. In the next video, we will, what are we going to do? In the next video, we're going to start dealing with me giving you a formula for f of x and you calculating all sorts of things based on that.